Hi everyone, this is our first question from network theory. Let us read the question first. The current I flowing through the 10 ohm resistor between A and B is. So here is the circuit. But before we proceed further, let us look at some prerequisites which will help us solve this question. So here are the prerequisites. Number one, when two resistors are in parallel, the equivalent resistance is R1 into R2 by R1 plus R2. Secondly, we need to know the source transformation technique. Here, a voltage source of value V in series with a resistor R can be converted to a current source with value V by R in parallel with a resistor R. Similarly, a current source of value I in parallel with a resistor R can be converted to a voltage source of value I into R in series with the same resistance R. So let us look at the question now. So here we can see that these 2 points I'm marking here are connected by a short circuit. That means the potential across this wire is the same. That means alpha and beta are equipotential points. So let us redraw this circuit, which will simplify our solution. So here I am taking the point A, and between the point A and alpha, we have 6 ohms. So let us write this. And between the points A and beta, we have a resistor of value 12 ohms. Here, alpha and beta are at the same potential. So indirectly, this 12 ohms is in connection with A and alpha. That means it is in parallel with 6 ohms. So this resistor will become 12 ohms. Next, anyways, this current source value is 10 amperes. So let us write that. This current source is flowing from the point alpha to A. So I have denoted the same direction here also. Then we have between the point B and alpha a resistor of value 4 ohms. So between B and alpha we have a resistor 4 ohms. And between the points B and beta we have another resistor 4 ohms. So here alpha and beta are equipotential points. So indirectly this 4 ohms is connected to B and alpha. So let us write it here. Then we can see a direct connection between A and B here with a 10 ohm resistor. So let us connect A and B with a 10 ohm resistor. Now, using our parallel resistance formula, let us simplify this. Here, a 12 ohm resistance is in parallel with a 6 ohm resistance, which is 12 into 6 by 12 plus 6. 12 into 6 is 72, 12 plus 6 is 18, which is equal to 4 ohms. Then we have two resistance here in parallel, 4 ohm and 4 ohm. So here 4 parallel 4 is 4 into 4 by 4 plus 4, which is 16 by 8, which is 2 ohms. Now let us redraw the same circuit again. So here the current source value is 10 amperes and the resistance, overall resistance in parallel with the current source becomes 4 ohms. And between the points A and B, there is a resistance connected which is 10 ohms. And between the points alpha and B, the equivalent resistance is found as 2 ohms. Now here is the right time to apply the source transformation technique. Here we see a 10 ampere current source in parallel with a 4 ohm resistor. So using source transformation, we convert it into a voltage source. As we know, the voltage source should have a value equal to V is equal to IR, which is as per Ohm's law. So V is equal to I into R, which is 10 into 4, so which is 40 volts. And the same resistance which is in parallel with the current source comes in series with the voltage source, which is 4 ohms. And these resistors will be as is. So the resistance between A and B is 10 ohms, and here the resistance is 2 ohms. Now look at the question. They are asking the current which is flowing from the points A to B. So which is flowing through this 10 ohm resistance. So they require this current. So as this is a voltage source, it supplies energy in this direction. So the current will obviously flow away from the the positive terminal of the voltage source. So the final answer which we want can be easily obtained by using KVL. So I is equal to V, which is 40 volts, by the total resistance in the network, which is 10 plus 4 plus 2, which is 40 by 16. 40 by 16 is 2.5 amperes. So the final answer which they are asking is 2.5 amperes. Thank you.